Potential energy of spring. When we compress or extend a spring, we experience a force in the opposite direction. Have you wondered why this happens? When a spring deviates from its mean position, it tends to restore its equilibrium position by exerting a force equal and opposite to the external force. But in which way can this force be helpful to us? Can we use it in any form? The energy gained by disturbing the equilibrium of the spring is utilized as its potential energy and converted to other forms. Now we will learn more about this stored energy. Let us consider a spring fixed to a rigid wall. The spring is assumed to be ideal and considered as massless. Initially, the spring is at the equilibrium position. Then it is stretched such that it gets displaced by a value x from its equilibrium position. Now it is compressed such that it gets displaced by a value minus x from its equilibrium position. In an ideal spring, the spring force is proportional to its displacement x from the equilibrium position. So, according to Hooke's law, F is directly proportional to minus x. So, F equal to minus kx, where k is the spring constant. The spring constant is the characteristic property of the spring. It depends upon the construction material and is measured in the units of Newton per meter. Now, let's calculate potential energy stored in the spring. We have pulled the spring such that resultant displacement equal to x is measured. The work done by the spring is given by W is equal to integration 0 to x fx dx, which is equal to negative integration 0 to x kx dx, which is equal to minus kx square by 2. Here the work done by the external pulling force Fp is given by kx square by 2, which is positive since it overcomes the spring force. The same is observed for a spring being compressed by a distance x. This work done is stored in the form of potential energy, which is given by U is equal to half kx square. So when spring is stretched or compressed, it has potential energy. What if it is at equilibrium position? It has zero potential energy. When spring moves from equilibrium position towards right, it gains potential energy. When it moves towards equilibrium position, it gains kinetic energy. Same happens when it is displaced towards left and vice versa. In spite of this interconversion of energies, total energy of system is always conserved. At extreme ends, its total energy is equal to potential energy, and at equilibrium position, its total energy is equal to its kinetic energy.